The real challenge of the pyramids wasn't their shape, it was the granite. Granite is quartz, feldspar, and mica, hard, stubborn, and brutal on tools. Yet ancient Egypt shaped it with apparent ease. The Great Pyramid's king's chamber is solid granite, with blocks up to 70 tons. The Valley Temple's joints are razor-tight. Single-block statues look machine-finished. Drill cores show deep spiral grooves that still give engineers pause. Manufacturing engineer Chris Dunn saw more than craft. He saw industrial precision, meter-scale flatness within thousandths of an inch. Drill holes true and round, cut straight and parallel over long spans. The copper and sand story didn't explain it. Copper is softer than quartz. It deforms before granite yields. Experimental archaeology tried. At Manchester, Dennis Stocks ran copper with sand on granite. Progress crawled, fractions of a millimeter per hour. Surfaces were rough, tools died fast. Dolerite pounding was even slower. Scaling to chambers and matching that precision? Not credible. Then a different lens. In a tribology lab, materials scientist Dr. Masoud Garb put a 4,000-year-old cut under SEM with EDS. He expected sand and copper. He found wear that didn't match sand, and corundum embedded in the grooves. Aluminum oxide, ruby and sapphire, hardness 9, just under diamond. Egypt has no usable corundum deposits. Using it well requires knowing hardness, sizing particles, and mixing controlled slurries. That's not luck. That's materials science. Replication followed in 2023. Same granite, same copper tools. 3 abrasives. Sand, dye 0.5 MER/hour. Rough cuts, heavy tool wear. Quartz, 0.8 MER/hour. Slightly better, still crude. Corundum quartz slurry, 3+ ME/hour. Smooth, clean, accurate cuts. In drilling, it produced the same spiral grooves seen in ancient cores, something copper and sand could not. Veteran stonemason Nick Giza said the moment the copper stopped fighting and started guiding the abrasive, speed rose and wear fell. Slurry cutting isn't plug and play. Consistency matters. Too thin, power drops. Too thick, grooves clog. Pressure and temperature must be controlled. That implies trained craftsmen refining technique across generations. 3 lines now converge: microscopy, replication, materials, data. At a late 2023 materials conference, engineers and physicists were largely positive. A geoarchaeologist noted abrasive slurries rarely survive archaeologically. Embedded corundum may be the best evidence we'll get. Egyptology was split. Good questions emerged. How much corundum was needed? Trade evidence, possible later contamination. While some dismissed the claim by attacking the messenger, not the data, stripped the noise. If ancient craftsmen sourced corundum, graded it, and mixed precise slurries, their profile changes. They understood hardness. They ran long-distance supply for industrial minerals the Nile didn't provide. They practiced real materials science. They weren't struggling with bad tools. They were mastering their world. And that raises a larger point. If an entire abrasive technology hid in plain sight for generations, what else have we missed? Because we never used the right tools to look? The proof is in the corundum, and the corundum is in the granite.